for coming here today. I hope all of you are doing well during this pandemic situation. My name is Amit Roy. I am a student of Techno Engineering College, Banipur, Department of Mechanical Engineering, third year. We all know that our department arranged a presentation competition named the Mechanical Way. In this program, I am going to represent my team, Smiling Buddha. My teammates are Abhoypal and Rohit Das. First of all, I would like to give you an overview of mechanical engineering. Mechanical engineering is one of the oldest and broadest engineering fields. It brings together creativity and design with maths and physics together to analyze and test the limits of products, process, and technologies. Mechanical engineering has always been present in the world, but the invention of the steam engine in the later part of the 18th century, providing a key source of power for the Industrial Revolution, gave an enormous impetus to the development of machinery of all types. As a result, a new major classification of engineering dealing with tools and machines developed, receiving formal recognition in 1847 in the founding of the Institution of Mechanical Engineering in Birmingham. Here you can see a model of a beam engine featuring James Watt's parallel linkage for double action. James Watt is known as the father of mechanical engineering. Before my presentation, Team Amigos Mecanzo talks about the evolution of mechanical engineering until 2000. They talk about some novel inventions like IC engine, jet engine, and of course aeroplanes and etc. And lots of other things. Now I am going to discuss how the mechanical engineering branch will evolve in future. Civil, mechanical, and electrical engineering are considered as the mother of engineering. In other terms, these are core branches. Look around in any non-mechanical engineering area. You will find mechanical engineering uses. Take civil industry, which is growing fast with the help of heavy, more precise mechanical equipment. Look at the electrical industry, which is also heavily dependent on the mechanical industry, starting from power generation, plant machinery to distribution network. Look at the chemical industry, which is also dependent on the mechanical industry in terms of chemical factory setup, equipment, and etc. Even you take medical industry, in which robotic operations, diagnostic machinery are mechanical equipment. The list is endless. Now coming to the future of mechanical industry. The future lies in the merging of multiple industries to create new and innovative solutions. Mechatronics is one such example in which mechanical engineering works with electronics. Did you see a common thread on all evolving areas? Robotics, space science, green technology, 3D bioprinting, IT, or anything else, all have a work with mechanical support. Therefore, if you are a mechanical engineer, be rest assured it is going to penetrate all industries. There is no end of possibilities of new solutions. Now let's deep dive into these 5 sectors of mechanical engineering. I am going to start with mechatronics. It is the field of study integrating mechanical and electronics principles onto a single device. Mechatronic systems are conglomeration of electronics, mechanical systems, and computer science. Examples include escalators, elevators, refrigerators, photocopier machine, auto sliding door, anti-lock systems, robots, and etc. Robots is inarguably among the most famous and well-researched offspring of mechatronics. Robotics is the field of study integrating computer science, electrical, and mechanical engineering primarily. It is a more specialized field of mechatronics engineering. Bipedal robots, rockets, self-driving cars, hyperloop currently being developed are all examples of mechatronic systems. Improvements and groundbreaking research conducted within computer science will simply boost robotic systems and ultimately mechatronics. According to me, as long as computer science, robotics will thrive. As long as robotics will thrive, mechatronics will shine. Now let's focus on aerospace engineering. Aerospace engineering is a branch of engineering that provides skills and knowledge to design, manufacture, and maintain spacecraft, aircraft, missiles, and weapon systems. Every developed nation is characterized by modern and large airports, airlines, rapid and fast transportation of goods and people. Globalization demands good connectivity between countries and cities within the country, which will only possible through the development of aerospace engineering. Good defense of the country needs economic and high technological capability of the nation. Fighter planes, missiles, rockets, ICBM means intercontinental ballistic missile, etc. Lots of aeronautical engineers are needed to manufacture and maintain defense aeronautical logistics. Flying cars are a possibility in the near future. Most people in the world and India may be able to afford flying cars. This will need a lot of aeronautical aerospace engineering to maintain and manufacture flying cars. In conclusion, in the long term, the scope for mechanical engineering in the aerospace industry is excellent. Next, deep dive into space science. I think there is no need to explain what is space science because we all know what it is. Mechanical engineers play a very important role in every mission by any space agency. I will try to highlight some major fields of work for them. That is design of launch vehicle, propulsion system design, thermal system design, trajectory design. Apart from these, there are many other activities where mechanical engineers are involved. We can hope a very bright and exciting time for space engineering is coming. Now, I am giving some examples of what we could get within the next 5 years. First one is GSLV Mk3. It will also be established as a reliable launch vehicle, although I am not sure how much will be used for commercial launch. The last experimental suborbital flight was successful and two more are planned. Next one is Chandrayaan 3. The third moon mission of India is planned for 2020, but it was delayed due to COVID-19. It will consist of a lander and a rover. The next one is solar mission. ISRO is landing a solar observatory for research. This mission is called Aditya L1, and the spacecraft will be placed in a critical point called Lagrangian point, which is very difficult. And the last one of this list is Venus and second Mars mission. ISRO is going to Mars for the second time and Venus for the first time within these 5 years. ISRO will try to send a lander and a rover to Mars this time for actual scientific research on Mars. So I think we are going to have colorful days even in the coming 5 years in our space research. The happy future of our space endeavor is waiting for us. Nowadays, the most obvious trend is green technology or environmental engineering. This stems more from government regulations that asking people to use more and more green technology. So things like solar cells, electric cars, hybrid cars will become popular within few decades. Yes, I know this is primarily electrical, but there are also mechanical aspects to it. Renewable energies like wind, solar, wave, hydro, geothermal, etc. are involved with many engineering fields like electrical, civil, chemical, and mechanical engineering. However, energy is a subject of the mechanical engineering branch. In many universities, there is a separate department for renewable energy in the faculty of mechanical engineering. Now, the last one of this category is 3D bioprinting. Three-dimensional bioprinting is the utilization of 3D printing to make artificial organs such as livers and kidneys and other vital human organs to test new drugs more accurately and perhaps eliminate the need for testing in animals. In the future, we may replace the real human organ with artificial organ. The 3D bioprinting process includes 3D scanning, model design, and printing, which is nothing but a part of additive manufacturing. Here we see some evolving areas of mechanical engineering from 2000. And now I can say that a mechanical engineer applies his skill and awareness to making only what you think truly serves a better world. I just give you some examples. Now I request my friend Rohit to discuss the next topic of this presentation.
Good afternoon, everyone. I am Rohit Das. Now I am going to discuss the contribution of mechanical engineering to move the world. According to me, mechanical engineers make things that I used to make every other thing. If mechanical engineer was not known to man, we would still be in the Stone Age. When the Stone Age man used a bit of mechanical engineer. Even to produce inconsiderable part of any item, we need to change the form of energy either from heat to work or from work to heat, which cannot be possible without mechanical engineering help. Actually, we cannot make anything without mechanical engineering. Now, I'll give you an example of a day of my life, so you can understand how mechanical engineering is work in our daily life. I wake up in the morning and check the clock on the wall. The hands movement on the clock is a product of mechanical engineering. I realize I'm late and rush to the bathroom. Take the brush and close the door. The door only got closed because of the hinge on it. The hinge is a product of mechanical engineering. I got ready and went to play some tennis. Then I took the racket. The racket is a product of mechanical engineering. Then I got ready and left for college on my cycle. The cycle is a product of mechanical engineering. In the class, the professor wrote on a blackboard. The blackboard is a product of mechanical engineering. After the class ended, I decided to go to the library. I wanted to go to the last floor, which is quite optimal for studying, and I took the elevator for it. And the elevator is a product of mechanical engineering. I studied for a while and it was terrific as usual. To overcome my sleep, I decided to watch few hours of YouTube video for a while and study later. But like every other student, I ended up watching 6 hours of nothing. But still, my laptop did not get heated because of the fan inside it. The fan is a product of mechanical engineering. I came back home. It was summer and freakishly hot. I immediately turned on the AC to get some sleep. The AC is a product of mechanical engineering. Now, we are very much eager to know the role of mechanical engineering in transportation. There are four main modes of transportation. Railways. Almost every aspect of railways relies on the mechanical engineering field, from trucks to signals, trains, ticket barracks, tunnel, even elevator control system are responsibility of engineers. Roadways. Mechanical engineers drive the automotive industry from 80-seater buses to single-seat F1 cars. Airways. Aerospace engineers are all about flight, whether that's plane, missiles, rocket. They design more fuel-efficient aircraft that cut emissions, build the fleetest of stylities that power modern GPS technology, and create the next generation of a spacecraft for mission Mars and beyond. Waterways. Engineers in the marine industry usually either opt for the mechanical machine vessels and equipment or design and build them. Designing of transportation facilities include our airport pavement design, toll plaza design, traffic design, signal design, lots of other designs for transportation that cannot be possible without mechanical engineering help. To keep it saturated, the Earth's rotation is a product of mechanical engineering. And yes, mechanical engineers move the world. Now I request my friend Abhay to discuss the remaining topic of this presentation.
Good afternoon, everyone. I'm Abhay Pal. Now I'm going to present the remaining part of our presentation. In this part of my presentation, first of all, I would like to talk about how mechanical engineering related to medical science. Have you heard about complex brain surgeries performed by robots in 20 minutes, which once demanded 2 hours of dedicated efforts by surgeons? There's a brief glimpse of mechanical engineering making inroads to surgical bed. But I will give another insight to help you grasp how mechanical engineering can diverge application in medical fields. Don't be surprised when I say mechanical engineers are fighting cancer. Chemotherapy is an extent treatment of cancer. In layman terms, this procedure can be explained by an analogy to treat a house infested with rodents like mouse. In order to kill the mice, should you use a rat kill or should you burn the entire house? I hope you would go with the first choice. But the chemotherapy is a medical in which your entire body is exposed to radiations. Drawing back an analogy from the rodent killing story, chemotherapy is like burning the entire house just to kill rats. So an ideal medical solution would be treating just the infected organ with radiations. Well, can be achieved by targeted drug delivery and the recent developments in microfluids, which is a core area of research in mechanical engineering. That can make this feasible. Now I have outlined a few areas in which both mechanical and biomedical works in. The first one is artificial organs, and second is pharmaceutical industries. As my friend Amit said earlier during discussing about the 3D printing, that we can see direct use of mechanical engineers in artificial organs of human, like artificial heart, cochlear implant, pacemaker, bionic eye, heart-lung machine, and lots of clinical devices like oxygenator, ventilator, and etc. And for the pharmaceutical industry, I want to say that where there is missing, there must be a mechanical engineer. Pharma has a wide scope for mechanical engineers, though they need VForm for QA, QC, and production department. But behind the curtain, there is always mechanical engineer for HVAC. That means the heat, ventilation, and air conditioning, which most important utility of pharmaceutical industry. Handling of all these utilities is the responsibility of mechanical engineer only. Now, I want to conclude this presentation after dedicating some sentences to mechanical engineering as a mechanical student. And the sentences are: we rule the sea, we make machines think. We trade beyond the world. When mechanical rest, the world rust. Where mechanical accuracy is our identity, leading is our motto. We are proud to be a mechanical student. Nothing is possible in world without mechanical. At the end, I would say mechanical industry is bound to grow to a limit that is not yet defined. The only limit exists is in your mind. So keep your mind and interest open and keep exploring new solutions which you may create for mechanical itself or other industries. That's cover just about everything what my team wanted to say. Now I would like to thank all of you for your time and attention. Thank you all.